Hello and welcome to another episode. This is another case study. This is a case study of batteries which were coming back after about 6 to 8 months of use. The battery manufacturer was puzzled and did not know why this was happening. When I visited the factory, I found that the battery design was robust and the standard operating procedures which were specified were being followed all through the process. These standard operating procedures were in line with industry standards and specifications. The quality inspection being done by the personnel in various departments were also of a good standard. In fact, the quality inspection procedures were also well laid out. The records of quality inspection were also easily available and they did not look to be something which were doctored or just written. In fact, the quality inspection was something which was really laudable. Now, I looked at the battery assembly and I found that even the quality of materials used for the assembly in terms of various components used were also good, and the assembly was also being done in a proper manner. Despite all this, the batteries were coming back. The problems as specified by the battery manufacturer was when he was supplying 12-volt batteries, four numbers as a set for any system, because most of his batteries were going for 48-volt systems. He found that the batteries were coming with different voltages in one system, and the cell specific gravities of individual batteries were also varying, and the variation in cell specific gravity was quite a bit when when he was confirming the cell specific gravity of 24 cells. So this was a major problem and it was affecting the backup because of this, and the problems were only increasing as the production was growing. I told him we need to check the battery charging log sheets. So I could see the log sheets and I found that the AH input as well as the charge current profile was proper and it was defined in a proper manner for various types of batteries. I checked whether the specific gravities were being equalized. That was also being done. Now, I said I would like to go and actually see whether this was being practically carried out by the people. I talked to the people and found that they were well trained and they were aware of the problem and they were doing all the work in a proper, regular manner and as was defined in the operating procedure. On checking the gravities, I found that they were all consistent. Despite that, this problem was quite a headache for the battery manufacturer. Now, let's see why this problem was arising and how could I solve this problem. So if you think that a battery filled with correct low specific gravity acid, charged at the recommended slow current and charged for correct charge duration and fed with the correct input AH and finally equalized with the same specific gravity in all the cells is a good quality battery that shall deliver the rated capacity and will also last long, then we seem to be mistaken because that is not the case. Now, in the case of this battery manufacturer, I noticed that the cell specific gravity in cell number 1, 2, 3, 4, 5, 6 were all 1.240. And despite that, this battery manufacturer was having problems of varying specific gravity. But what I also noticed was the temperature in the various cells were varying. So when the first cell was having 1.240, the temperature in that cell was 36. Similar was the temperature in cell number 6, where it was 36. However, the cell number 2 and 5 were warmer cells. The cells had a 42 degrees centigrade, and the cells in the middle were having a much higher temperature. The temperature was 52 degrees centigrade. Naturally, this was one of the causes of the problem that this battery manufacturer was facing. Because what happens is when the cell specific gravity is measured at 36 degrees as 1.240, when it is corrected to 25 degrees centigrade, it becomes 1.248. Similarly, the second and fifth cells, which were having 42 degrees centigrade, the cell specific gravity will rise from 1.240 to 1.252 after the battery cools down. Whereas the cell number 3 and 4, which were having a very high temperature of 52 degrees centigrade, the cell specific gravities will change to 1.259 when it is corrected to 25 degrees centigrade. So what is measured as 1.240 in each of the cells is not actually 1.240 when the cells cool down. So the corrected specific gravity is varying from 1.248 to 1.259, and this cannot be noticed by the person who is actually leveling the battery uh, electrolyte level and who is correcting all the specific gravities to 1.240 and then giving it for packing and dispatch. So the cell specific gravities, because they are varying, the customer or the distributor is receiving the battery right in the beginning at the time of receipt with varying specific gravities. The very next questions which popped up were, what needs to be done? Is it possible to get over this problem? What is the solution? Well, what needs to be done? The temperature and specific gravity have to be related, and a specific gravity correction related to temperature needs to be done. Is it possible to get over this problem? Of course, yes. A chart needs to be prepared of the specific gravity at various temperatures, and we need to know what is the real specific gravity when the temperature is at a particular level. The another way of doing it is having a required specific gravity and mentioning in the chart as to what should be the specific gravity adjusted to if the temperature is varying to say 36 or 42 or 52 or 59 or whatever it is. Of course, 59 is a very high temperature. Generally, the temperature is not allowed to go over 55. But then such a chart can be prepared and given to the workman. So what is the solution? Now, it's not easily possible for everybody to relate and calculate the specific gravity with respect to temperature. So if there is a calculator available, and if I tell you that such a calculator is available, you can go ahead and use it. So which is this calculator? The calculator is BATEC, and this calculator is now available for free, and on the Google Play Store, this can be downloaded. A one-time sign up is required, and this calculator can be used on a regular basis. It shall be available for free use on the Apple App Store after a few days. So you need to register only once, download this app, and start using it. Now, the calculators which you need to use are these two: the reverse calculation for specific gravity with temperature correction, and the temperature correction of specific gravity to a defined temperature in degree centigrade. If a chart is prepared based on these calculators, it's easily possible for the workman to follow the chart and adjust the specific gravity with respect to temperature. Now, this is how the calculator looks. It's very simple to use, and there are many calculations which you can avail of, and you can also see what are the various calculators which are available in this app. In case you want to get in touch with me, I have given that links to the various platforms which you can visit. These are the podcasts to which you can navigate when you use the app. This app is also available in Hindi, and it's possible to shift from English to Hindi or Hindi to English. Now, these are the various calculators which are available, and there are approximately 30 plus calculators, and you can use all these calculators. I, I do hope you will use the calculator and not face problems of the kind that this battery manufacturer was facing. So you have to relate the specific gravity to temperature and do the correction accordingly so that you do not face problems of the type that this battery manufacturer was facing. Thank you very much for tuning in.